So guys, today's topic is quality of service, and then IPv6. Okay, two topics only. So first, quality of service.
Sir,
Yeah.
these two are big topics.
No, it's not a big topic. It's normally one hour topic.
Then I have to query for yesterday topics, wireless topic, related channel and clock speed.
So again, quality of service. So just tell me where we are using the quality of service and why they introduce this quality of service. Yes, any idea? Quality of service. Reliable transmission. Anything else? Okay. So, Rakesh, any idea like what is the quality of service and why we are using?
It is through quality of service we can fix the bandwidth for particular service. So like that we can define for internet like I have 100 Mbps speed, then 80 Mbps I will reserve for internet, 10 Mbps for voice, 10 Mbps for different service, like that for service related. But not work on this. And heard about this how why QoS use
Yeah,
to reserve bandwidth.
yeah,
for
mainly we
particular
can
service.
reserve our bandwidth for the different services. Okay.
Right.
Introduce. Suppose you have an organization. Okay, this is your organization. Here, some users are doing video conferencing. It means your voice and video graphic and video. Then here, we have some user. They are trying to download something from the internet. It's downloading. Here we have one router. Now your router is connected with the ISP. And you purchase one, like we purchase some internet with the speed of like, you can say 2 Mbps. 2 Mbps for speed we have. Now this user, like I have one user is trying to download something, like it's trying to download some movies or some series from the Google, and with some third-party software like IDMs and all. So with that is going to consume all the bandwidth. So we have the 2 Mbps speed, and my all speed is consumed by this downloading. Now here we have some user is trying to do some video conferencing with his client, but my all bandwidth are consumed by this user for the downloading. So when I'm trying to send my voice and the video data through the internet, so I'm getting some disturbance. Why? Because we don't have any bandwidth and load, because all the bandwidth, all the speed is consumed by this downloading. So suppose if you are doing some conference, if you are doing some video conferencing with your client, and you are facing some disturbance in the videos and the voice. So maybe they are thinking like, okay, you can't maintain your internet speed, so why should I deal with you? Why should I give you my order and all? So that's why for resolving this kind of issue, what we can do, normally when you are doing voice call or video call on the WhatsApp, so how much speed you need for video and voice call? In KB or MB? KB is like 500 MB, 500 kbps or maybe 1 Mbps is enough for the video calls. So with the quality of service, I can reserve some traffic and some bandwidth. Like this is my voice and video call data, this voice and video data. For voice and the video data, I'm going to reserve 1 Mbps speed. 1 Mbps speed I'm going to reserve for the voice and the video data. And the rest of all traffic, the rest of all user, they can use for downloading, uploading, surfing, whatever they want. But for the 1 Mbps, I'm going to reserve for the voice and the video traffic. So when I'm doing any video conferencing with my clients, so I'm not getting any disturbance. I can send easily my voice data and I can receive my video data as well. Uploading and the downloading, we are receiving good speed. So this is your quality of service. Now, why they introduce the quality of service? Why? Because we have, you can see here, I have very less bandwidth, like I have only 2 Mbps speed. Sometimes it depends on your device also. Like, have you heard about the delay? What's the meaning of delay? Delay. Late. Okay, Hindi word is late. Delay. If you want to send any data from one side to another side and you are like I'm sending hi message right now at 8:20 and that party is receiving that hi or hello message at 8:25 or 26. It means we are facing lots of delays. So suppose this is my environment, router 1. This is your router. Here we have some cable. Cable. This is your cable. Now any user is trying to send any packet, like here we have one PC and here also we have one PC. Now this user is trying to send any data from PC1 to the PC2. PC1 to PC2, like this. But when your packet will reach to the router, okay. So in the router, we have some backend process. Suppose it's my router, like I configure my REPR, GRP, and OSPF for routing protocols. It means I'm advertising some data. So data will reach to the router. Now in the router is a new packet, so we have to do some processing. So for the processing, we need some CPU. CPU, it means clock speed and all. And like normal Windows PC also, we have like i3 processor, i5 processor, i10, then third generation, eighth generation, like this we have. What this means? Like it belongs to your processor speed, clock speed. If you have numbers of clock speed, it means your processing speed is very high, like in the signal. If you have clock speed is very less, it means your processing speed is very low. So suppose this is my outdated router. And I'm trying to send the lots of data from one side to another side. So that packet will reach to the router. Now it's going to do some process. So it's called a processing delay. It's going to do some processing. Then after the processing, we have to like, okay, I process my data. This is my routing table. I have to update in this. Then I have to forward the data to some different location. It means that this data we have to forward via this link. But as I told you here, we have a like very less speed. My bandwidth is only 1 Mbps. And my data is like more than 1 Mbps, like 10 Mbps and all. So directly I can't send my data. It means so first I have to like, before it, have you heard about the queue and stack? What's the difference between the queue and stack? And what is it, the queue and stack? First in, first out, last in, first out, LIFO and FIFO. It means like this we have, it's called queue. Like this. Okay. So if I have any data, it's reached to here. So first we have to process this data. Then we have some second data, third, fourth, fifth. So one by one, we have to execute this data. Okay. So whenever any packet is reached to the router, after your processing, like after your CPU processing, if you have very less bandwidth, then the data is put in the queue like this. So your data will come here in the queue. Until and unless we are not clearing our first data, so rest of all data is remain same there in the queue. So this is one kind of also is a delay, and this is your queuing delay. Okay. After the queuing delay, suppose this is my data. This data will reach to the router. After reaching the router, is going to do some processing on the CPU with the help of the CPU. After CPU processing delay, it will come into the queue. That queuing delay. Now we have to send the data to our destination. So after the queuing, we have to put the data into our cable. Okay, it's called like a serialization delay. Then we have to convert the data into the bits and bytes. Then we have to send in the cable. So like you can see here, how many delays we have. We have a processing delay, we have a queuing delay, we have a serialized delay, we have a propagation delay. So this much delays we have. So, when we are converting our data into the bits and bytes. Okay. So when you are sending our data from one location to another location, it means this much delays you have in your environment. So suppose without quality of service, when in your environment you have one user and he's trying to download something, it means your first packet will come here for downloading. Okay. Again, second packet also is a downloading. Then we are receiving any voice packet. Voice packet, voice packet, voice packet, like this we are receiving. So your router first is going to send this downloading data. First is trying to execute this process. Then again this process, downloading. So suppose for downloading, your CPU is taking around 1 second like this. 1 second, not more than that. After the 1 second, like here we have a 2 second, and after the 2 second, my voice data is coming to your to the link. Then we have one more delay like propagation and serialization. So around like here we are receiving 3 second delay. So suppose you said hello, and after 3 seconds, your hello voice it reached to your destination. You said lots of things, and after 3 and 4 seconds, your receiver receiving okay what he said. So it's not a good thing. Okay, somehow we can manage with our friend circle, but this kind of things we can't manage. It's not a good sort of things in our real environment. Suppose if you are doing video conferencing with your client and if he is feeling some disturbance in your network, so might be he will cancel your bill. And so we have to avoid this kind of scenario because we have lots of delays, processing delay, queuing delay, propagation delay, serialization delay. So with the help, we have lots of delay in our environment. But my task is I want to forward my voice data without any delay. It means I can prioritize this data, voice and the video data. Whenever this data, voice and the video data will reach to your router, like it will reach to the router and is going to say, is going to check, okay, this is very high priority data. So first we have to execute this data. First we have to execute this data and forward this one. Okay. And also we can allocate some bandwidth, some speed for particular this traffic. It means we can prioritize the data. We can mark this data, we can categorize this data. Okay, this is very high priority. Then we can allocate some specific bandwidth, like whenever I am receiving voice and the video data, please give them as a 1 Mbps speed or 500 kbps speed. Default is a like we can assign some bandwidth and so. So with the help of the quality of service, we can achieve this goal. Mainly why we are using quality of service for we have to forward our important data as soon as possible. So in our real environment, your voice and the video data is very high priority data. We have to send as soon as possible. If we are feeling some disturbance, like if you are getting some delay in your downloading, not any issue, not now. Like after 1 hour, we can download it. The data. But if you are sending some voice and the video data, so it's very high priority. We have to send that data as soon as possible. With the help of the quality of service, we have to achieve this goal. Okay. And also we have one more thing. This one is clear. Now we have one more thing. Suppose I have this one. Suppose I have some speed issue like here for the home router. Suppose I have 512 kbps speed. Now suppose some attacker is coming to the picture and he's trying to send lots of data, multiple data. Like, have you heard about the attacks, DOS attack, DDoS attack? Okay, in that what happened? In the DOS attack and the DDoS attack. What is a DOS attack? Online guys, what is a DOS and DDoS attack? Online guys?
No idea. No more idea for this.
Really, no idea.
No, it is generating lots of traffic and making device hang, or it is utilize full bandwidth of that interface. Continuously, it is generating the packet and packet.
Like I have to down this system. Okay, in real environment, it's not normally. I have one router. Okay, it's working fine. I'm receiving some packet and processing on it. Means I'm occupying my CPU. So with the help of the CPU, we are processing the data and then we are forwarding from one interface to another interface. This is the normal scenario. I'm a taker. Okay. Continuously, I'm sending the data continuously, and very heavy packet I'm sending. So one packet will reach to the router. Your router is going to process. Then again, continuously, I'm sending the lots of traffic, lots of in thousand and lakhs packets I'm sending at the same time. So lots of packet is going to hit your router. So your router is trying to execute. Router is trying to process on each and every data. It means all the CPU is going to occupy for that process. Still, I'm receiving the data. Okay. Meanwhile, suppose any user is sending a very important data. When it will reach to the router. So already in the router, we have lots of remaining packet. It means we have very lots of queue. So your packet will drop. Like in this also, we are putting our data in a queue and this stack. It means we have some limitation. This much data or this much amount of data only I can put in my queue and the stack. Suppose your stack full, like your bucket is full. Then what happens? If you are putting more water, then it's going to same. When if your stack or the queue, when your stack and queue is going to full, and after that you are receiving any very important data, if we don't have any space to store that data, it means definitely by default is going to drop that packet. So no one can access the internet, no one can send the traffic from one location to another location. So with the help of the DOS and the DDoS attack, we can do this kind of scenario. We never try these things. DOS attack, DDoS attack, man in middle, keylogger, sniffing, spoofing, email attack. No, never. Nice. Huh? In the DOS attack, like we are sending traffic from the one PC, but in the DDoS attack, we are making the zombies of the lots of PC, and then we are trying to attack. We have lots of free softwares on the internet. Just go and search and use it. Okay, so this is your DOS attack and the DDoS attack. Like then we have the you never use like keylogger. Have you heard the keylogger? Keylogger. There is some softwares and the hardware. If I install that software in your PC, and whatever you're typing in my PC, whatever you are hitting the keystroke is going to note it down your keystroke. You are visiting some website, it means you are typing some website name, it's going to make on log. You are typing your email ID, you're typing your password, you are doing some online transaction, it means you are typing your card details. All that keystroke is going to store in your system, and after 1 week or 1 month, I can come and I said, okay, can you please give me your laptop? I'll take your laptop and I can get all the data and I can use it. And if I have some money, so I can purchase the pro version after each and every 1 day, after 24 hours, all your keystroke is going to send to via my. How to learn all these things, security topics. And we use these things in college time. And so lots of passwords and all, and we use it. Yeah, attacks. So suppose like someone trying to, like in networking, we have one attack, synchronized flooding attack. In the TCP, TCP is a reliable connection oriented. Before the sending our data, we have to establish our connection. So for the for establishing our connection, we are using some three-way handshake. Okay. In the three-way handshake, we have some three packets. Tomorrow we will discuss about these things. So in a three-way handshake, first client is going to send, okay, I want to communicate with you. Okay. I want to communicate with you. So your client, your server say, okay, let's make a secure channel. Then client say, okay. Online based, just 5 minutes.
Yes, sir.
After 5 minutes, not 5 minutes, after 1 minute, again join with the same link.
Okay.